Once again, I find myself with some downtime while I wait for an order of some ceramic caps to arrive for the tandem set, and I'm also waiting for a coat of finish to dry on the tandem cabinet. So, I thought I'd take a look at this. What this is a TV, although I know it doesn't look like one, because it's already been partially disassembled. This is my friend's set. He has 4 or 5 of what is known as a bug-eye TV. Those are portable metal TVs made by Zenith in the late 50s, I think from like 57 to 60 or thereabouts. This in particular is a 58 model. Well, he thought he'd do me a favor by already disassembling the set, so he just dropped off the chassis. So what you see is actually all I have. No picture tube, no speaker, obviously no cabinet. And he also plucked the tubes out for the most part, although I see there's still one down there. So, this is all I got. Well, the speaker's no problem. I've got some speakers lying around I can hook up. And he did also drop off a box of tubes, so I think I've probably got most, if not all, the tubes in this box. Otherwise, I can hunt around my tube stash to see if I have the rest. I looked up service info, and I don't have the Sam's, but I did find it in the Beatmans for 1958. So I've got a diagram showing tube layout, the controls, and alignment instructions, schematic, and so on. So I think that will be sufficient. Also, I've got a bag of parts. I ordered up enough parts to restore 2 of these, I think. So that leaves the picture tube. Well, I thought that'd be no problem. I can just use one of my test CRTs. Until I checked out the schematic. And it turns out this is a low filament current set. Just like that Philco Town and Country. Most tubes run on 600 milliamps. Certainly they all do in the transformer-based sets I've got. And quite a few of the series strung sets like the Predictors. But this runs on 450 milliamps, including the picture tube, which is a 14XP4. I don't have any picture tubes that run on 450 milliamps. They're all 600 milliamps. What I was hoping to use is this guy, 8XP4. And I was thinking, it's probably in the same family, 14XP4, 8XP4, probably compatible. Well, no, they aren't. This is 600 milliamps. However, I think I still have a shot at being able to use it. One, it's possible that even at 450 milliamps, it'll produce a watchable image, because it's a pretty strong test CRT. I think it's barely ever been used. In fact, it might have been brand new when I got it off of eBay. So even at a reduced filament voltage, it might have decent emissions. Otherwise, a good fits too. Otherwise, what I can do is hook up an external power supply for it. Here's the back side of the chassis. So you can see it's a 15A25. Here's where the power comes in. Goes through a fusible resistor, capacitor, 2 selenium rectifiers, another filter cap. That forms the heart of the power supply. I've taken a schematic and simplified the power supply from all this down to just this. So here is 117 volts in, and as you can see, it is a hot chassis set. One side of the AC switch is right to ground, which is the whole metal chassis frame. So definitely want to use an isolation transformer when you're working on this. Alright, so this thing is all the tube filaments lumped together. On the original schematic they show them all along here. They're all wired in series. So I took all the tube filaments, added them all together, 105 volts AC, running 0.45 amps. No, 105 is less than 117, so they throw in a 27 ohm resistor. 27 ohms with 0.45 amps running through it is right about 12 volts. Dropping across here, 12 volts plus 105 equals 117. Now typically in the US we have more like 125 in our outlets these days, so not a bad idea to increase this to say 33 or 39 ohms. Alright, so the rest of this is the B plus power supply. This is what powers all the tubes, all the plates. So this is pretty standard for series strung sets that use voltage doublers. My tandem sets, or I should say the Philco Holiday and the tandem sets I've been working on. The Motorola VT71s. Some of those portable sets I started recently, like the Motorola set, they all use the same basic configuration. So this guy is a fusible resistor, like one of these. Serves two roles. One, it's a fuse, so if there's too much current being drawn, this will burn out safely. Two, it limits the surge current. Selenium rectifiers, it's my understanding, cannot take a strong surge current. So when you first turn this set on, these caps want to charge up, so a big current draw through it. Without this resistor being in here, these could burn out. However, I'm going to be replacing these with modern silicon diodes. I know it's a topic of some debate. Whenever the topic seems to come up on the anti-radio forum, it starts quite a lively conversation about the pros and cons of replacing them. The general argument goes that if they test good, why not just leave them in the set? But having personally experienced one of them go up in a cloud of smoke, I replace them. It's a really horrific smell, not too safe to breathe in either. So, modern silicon diodes can withstand the surge current. So if you replace these with modern silicon diodes, I think you could dispense with this and just put a fuse in there. These suckers get hot. That's the one reason I'm not crazy about them. Now the other issue is that silicon diodes are more efficient. See, selenium rectifiers are big and they have all these plates on them. Well, that's because they get hot. Because there's some loss in these. So each one of these plates loses a volt or two, something along those lines. So across this whole thing you might lose like 10 volts. Well, silicon diodes don't have that problem. Or, well, they do drop a little bit, but it's more like 0.7 volts rather than 5 or 10 volts. So you just go with two silicon diodes plus 125 volts AC here. You're going to get more than 245 here. It might be more like 265, 270, something like that. Which may be okay for the set, but it also may be a little too much and you might be stressing out components. So good idea to drop that down if you can. Traditional way to do it, throw a couple resistors in series with silicon diodes to simulate the loss in here. Which is fine. You know, it's been done many times, works just fine, but you do need to figure out what this value is, and they do get hot and you got to find somewhere to mount them. So got me thinking, how can we eliminate that? Because if I could avoid having to put power resistors in here and get rid of this guy and just put a fuse in there, hey, that's a whole lot of waste heat we're getting rid of. And these metal portable sets, because they're confined, they can get pretty toasty. So if we don't have the resistors and the diodes don't lose much voltage, how can we get this down? Well, you could run this off of like a variac or I think I call it a buck boost transformer configuration to drop down your voltage on the input. Or how about we take a look at these? There's a voltage doubler. It basically works by, it charges up one cap on one cycle of the AC input and the other cap on the other cycle. Then the voltage across both of them in series appears here, so you get Well, basically double the voltage. 120, 120, you get about 240 out. Well, where do these values come from? Well, what's this 140? Where did that value come from? Well, I looked online and it seemed like a simple question. I figured if you know what your input voltage is, you know what you want your output voltage to be, and you know what your current draw is, there's got to be a formula to figure out what this capacitance value is. I couldn't find one. But I know that value is important. If you use too small of a capacitor, it's not going to hold enough charge on the alternating cycles, and you're not going to get a full voltage doubling. So I was thinking, well, hey, what if I forget about putting resistors in here? How about I just drop the capacitance down? Maybe 120, 100, 82, 68. So I've got a few caps on hand, and that's what I'm going to try doing. I'm going to try using a smaller capacitor here and just empirically, experimentally, figure out what value of capacitor will get me this lower voltage. And if you're thinking a smaller capacitor, maybe introduce more ripple, remember there's a big old filter cap out here too. And if need be, I could always increase this from 100 to a higher value to eliminate any ripple that might be there. So anyways, I thought that'd be something fun to experiment with. Now, as far as restoring the set goes, my friend does not care about restuffing cans or polishing chassis or anything like that. He just wants a set that works. So I'm not going to go to any extreme lengths. Let's see how quickly I can get this set resurrected. So here is that one filter cap, the one that goes right on the AC input, this guy here. It's covered in cardboard because it's not grounded on the outside. The negative actually goes right to the AC line. That's the curved part here. That's the outside of the can. That goes right to the AC line. So you don't get shocked if you brush up against it. So there's one cap, and the other one is the one I showed on the other side next to the rectifiers. So I want to find somewhere to stick in some new caps. As far as the rest of it goes, this is a construction style I've read about online, but I've never actually worked on before. Instead of terminal strips with the leads wrapped around and soldered on, there's these little cups. I got these strips here with little cups in them, and they stick the component leads into the cup and then fill it up with solder. So I believe to get the old parts out, you just heat these cups up and the leads just pull right out. No unwrapping, no clipping involved whatsoever, so I think that'll go pretty quick. But before I get too far ahead of myself, I think I better check the critical components, being the yoke and the flyback. There are resistance values indicated on the schematic, so resistively check the coils. There's the flyback. Doesn't look too bad. Some cracks in the insulation, but doesn't look like it's catastrophically failed. Of course, it doesn't mean anything. I need to actually measure the coils. You never know, there might be a break or a short inside there somewhere. And I'll also check this guy, which I think is the filter choke. And there's going to be a vertical output transformer on this set somewhere. I've been replacing the caps without incident, and then I turned my attention for a moment to the controls. These bug-eye sets are a little weird in that most of the controls are on top, and some of the controls have little knobs that stick out. Some I think you just turn with the little knurled shafts here, or maybe you have to use a flat-bladed screwdriver for some of these recessed controls. Well, I thought I better start checking them, and I noticed some of them are really, really stiff and grungy. I imagine part of that is because these controls all face up, and there's holes in the metal chassis, and over the years, I'm sure moisture and dirt and grime get down into the controls. Like, you can see how it's kind of corroded around here, and that control's really stiff. So I'll spray some dioxide into these and see if I can get them to work a little bit better. And then I got to this one. This is the contrast control. A big old fat wire wound control, and I cannot get this to move at all. Also measures a bit odd. They show it as being 7K. I'm measuring about 11K across it. So I am going to unsolder the terminals, and these things are kind of cheap in that they're not even held on by nuts. They're little twisted metal tabs there, so I'll have to straighten those out and get this off and take a closer look at it. I carefully pried the back off, which revealed a rather nice wire wound control. No corrosion or obvious signs of any mechanical defects, so I sprayed it good with some deoxit, worked it all down in there to flush out any maybe old dried up grease or whatnot, and did the same on this. There's like a lock washer on the shaft there, and then I applied a few drops of the needle oiler and applied a little bit of white lithium grease and just worked at it and worked at it and worked at it, and there we go. It works just fine now. So I'll put the cover back on and reassemble it and wire it back in. I unmounted those two big selenium rectifiers, which gave me plenty of room to install a terminal strip and some new components. So here is the fusible resistor. Here are two silicon diodes. I'm using one N4007, which are rated for 1000 volts and 1 amp. And here are the caps. This cap replaces this can, and these three were inside here. So this guy is this. And this cap here is this guy, and this final filter cap is this big guy here. This is used elsewhere in the circuitry. Originally these two were 140 microfarad. I put in 120s, so we'll see what that gets us here for our voltage. If it's too high, I can try knocking these down to 100 or 82 and so on. Once I get the voltages where I want them to be, I'll mount these a little more securely. I also went ahead and repopulated all the tubes and cleaned them up while doing so too. Except for one, which is a horizontal output tube. Went in here. When my friend had removed the tubes, he pulled the cap off the tube, which is stuck down inside here, so I'll pry that out and see if I can reattach it to the tube. I was able to pry that cap out, and it was a pretty tight fit, so I can see why this pulled off the tube. And I can work out these blades a little bit, take some of the tension off that. Then I took some solder wick and removed the solder from the top of this to reveal a little hole there, and that's where this lead needs to be connected to. Most of the filler's still here, but there's a chunk missing along this side, which I imagine corresponds to the chunk still on the tube, so I go on about like so. Alright, that's a pretty good fit. You can see a little bit of the lead is now coming through the cap there. So I could just solder this back on right now, but if I do that, odds are pretty good this will pull off again. So I want to put some adhesive down there. I've used this in numerous previous videos. Permatex windshield glass sealer does a pretty good job on these, fixing up these tubes, both bases and plate caps. Don't use super glue. Super glue doesn't take heat very well, and it will turn brittle and just crack off, flake off over time. A little bit on this too. There we go. Nice tight fit. Wipe off some of the excess. Yeah, sure, I could just toss this tube and install a new one, but looks like a pretty decent tube. Doesn't seem a lot of use. It's a tungsol replacement. About half of the tubes I found in here look to be the original Zenith. But this tube looks like it's barely been used. Usually these horizontal output tubes get rather discolored after they've been used for a while because they get driven pretty hard. Haven't tested it though because I didn't have this cap. So if I get this cap soldered on and glue so it's up a bit, I will test it and hopefully it was worth the effort to try resurrecting it. It's a 17DQ6 in case anybody's interested. For a little solder. I finished installing the replacement electrolytics. Also reinstalled the repaired contrast control, the repaired 17DQ6 tube, and I did install the 8XP4 test CRT. If it works, great. If it doesn't, at least it'll give us filament continuity so I can power the setup and hopefully get some sound out of it. I've got my ohm meter attached right now to the AC input, and if I turn the set on, hopefully we get some continuity. There we go. Turn it off. It should go to infinity. Alright, so next I'm going to plug this in to an isolation transformer. And I'll put a light bulb in series with that too, just in case, since I've never powered this setup before. Oh, and I'll monitor the B+ voltage while I'm doing that. Alright, let's give this a try. Turning on now. Good sign. Bulb lit it bright and dimmed down. I see the tubes lighting up. Got 200 and... well, it was 280, now it's dropping down. 245 would be the magic number. I got my variac turned down a bit to like 110, and of course I got the light bulb in series, so it's going to cut things down. Well, it's a very good sign. Looks like I didn't make any critical wiring mistakes on the filter caps or the voltage doubler, and all tubes have continuity through them. Alright, so next I'll take this light bulb out so we can get more voltage going to the set, and I'll hook up the speaker. Okay, here goes a full power up test. Shot up to 337 volts right away. 338. Should drop as the tubes are conducting. It's a good sign. just went below 245, but then again I do have the variac still turned down a bit. And we get buzzing out of the speaker. Let's see if I can pick up anything on channel 6. Yes, I can. This with no antenna. Grab a high voltage probe and see if I have any high voltage. No, nothing whatsoever. No high voltage. I didn't think so, because I don't hear any signs of life in the horizontal section. Alright, so I'll have to start investigating there. After I turned the set off, I was poking around a little bit around the Flabberg area, and I noticed that the horizontal output tube was really, really hot. That's not a good sign, so I mean, there's something wrong with the drive signal to it. Probably the horizontal oscillator isn't running properly. I tried swapping out the horizontal output tube and the horizontal oscillator tube, made no difference. I suspect there's something wrong underneath the set. So I'll start checking. That is this area down in here. You got these big power resistors. I didn't change a whole lot. The resistors I checked all seem to be alright, for at least in the horizontal output tube area. There are only a couple caps to replace. Horizontal oscillator, I believe, is over in this area, so I think that's where I'm going to start checking. I don't have the SAMs for this. All I've got is just basically this one-page schematic here. So I don't have any waveforms or anything to really check, so I think I'll ask around and see if I can get the SAMs for 15825 chassis.